welcome back to the second installment of the LangChain output parsers. This is Just Code It, and we're going to walk through some of these parsers today. Like always, you can choose any of these LLMs. I'm going to be using the Open Router one that I've been using lately because it's free. We're just going to load them in and run a little example. Okay, it looks like everything's working. First up, we have Pydantic model. We're going to import prettyprint SPP, import from Pydantic, base model and field, and then LangChain prompts, prompt template. We're going to define a class, which is going to inherit from the base model, and then we're going to basically define a couple fields, title, year, and director. Then we're going to give it the field and then the description of that field. So this is what the LLM is going to be using to query. Creating the Pydantic model, we're going to define the query. We're going to be querying these movies. Then we're going to be querying these movies for the movie inception. Then we're going to create the parser, which is the Pydantic output parser. We're going to pass it the Pydantic object, which is our movie class. After that, we will be creating the prompt template again, where we're going to create a template which has the format instructions and then the query with some new lines in there. The input variable is going to be the query. The partial variable will be the format instructions, which basically is created from the parser get formatted instructions. We'll see what that is in a second. And then we're just going to print out that dictionary. So those formatted instructions are this right here. Basically, it's just saying it's a JSON instance with a schema. Here's an example. Then we have our template right here, where it's basically going to do formatted strings to create this. Like always, after we do that, we're going to create that chain and then invoke off of it our query. And our query is that movie. So the inception string above, we're going to pass in. So it's going to query for that exception string, looking for that movie. And what we get back is that Pydantic model where we get the title is exception, the year is 2010, and the director is Christopher Nolan's. These Pydantic models can be really useful with databases. So you'll create the Pydantic model, which represents your schema in your database, and it basically validates this data before you then push it to your database, making sure you don't have any errors in there. After that, we're going to go look at some YAML parsing. These are all very similar. Again, we're just going to use a Pydantic model. The model has setup and punchline for the joke, and then we do joke, tell me a joke, which is the query. Define the parser, pass it a Pydantic model, which is the joke. Then we set up that prompt template that we've been using. From this prompt template, we're going to say answer the query. It's almost identical to the previous one. Pass it the format instructions and the query. Input variable query. Partial variable is the formatted instructions. Create that chain. Let's first take a look at this prompt though. The formatted instructions are a lot like the Pydantic one. It's saying you're going to respond in YAML, and then it's going to give an example of how the schema we want it to respond with is. Now let's add back in the other stuff. Now we can invoke off of that, and after we add it back in, comment out that print, it's causing some errors. Invoke off of it. This is why LLMs are not the best for standardized data, because it will work sometimes and it won't work others. What's the temperature on our LLM? And crazy. Let's get rid of that. Go back down. Run it again. And yeah, only took a few times. I'm also not using a very big model. So if you're using GPT-4, it will probably be better than this. But here we have the output, which is handing us back a Pydantic model. Next, we're going to take a look at some ways of fixing these output parsers. And there's one way that allows you to automate it. You can use it in a try catch area where if there's an error on an output parser, you can just retry again and it increases your probabilities of one of them being correct. What we're going to do is define that date parser, misformatted, and then we're going to use the output parser, invoke misformatted, and then print. And as you can see, it was able to then correct that for us. We can also use the new parser. So we're going to do output fixing parser, which is from those LangChain output parsers. And then we're going to do from an LLM. Parser is the output parser, which we just used. And then the LLM we're using, that will create a new parser. And then we will pass it the misformatted text. So let's create the new parser, misformatted text, and as you can see, date, date time, and it has it correct there. And those are just two quick ways that you can see if you can fix it on the fly. It takes a little bit more time, but it's better than having your application error out on something as stupid as a date time. But honestly, if you're asking for date times, just write a little bit of code and get it yourself because LLMs aren't the best at. That is it for output parsing. Up next, I think we have serialization, where we're going to learn about how we can save these prompt templates and load them back in. I hope you enjoyed today's video, and I'll see you next time.